Okay, welcome to the BPL Heritage session, and welcome friends and colleagues, and it's marvellous to be given this opportunity to look back at our past and to see where we've come from and to understand why we are the powerhouse of Kedrion. So we're going to be looking at the history of the site over the past 122 odd years, and in order to kind of capture what the kind of essence of the site, the words blood, plague and smallpox seem to be the most appropriate, because they're the key contributions that this site has been making to science, medicine and healthcare over this period of time. So we have on the screen now perhaps the oldest map we could find from around 122 years ago, showing where the laboratories came from. Okay, so let's begin. So if you can imagine now, we're back in the Victorian era, and over in France there's the Pasteur Institute, and it's already made a great success by pioneering the world's first rabies vaccine. And this was set up by Louis Pasteur, who gave us the safe treatment of milk. And a number of people in the UK are looking enviously, because there's no equivalent scientific institute. And the Lord Mayor of London, a Henry Isaacs, gets together with a group of industrialists and scientists, and they say, we need something over here that can pioneer medicines. Because at this time in Victoria and Britain, particularly in London, it's rife of diseases. So they approach Joseph Lister, or the first Baron of Lyme Regis, to be a figurehead for a scientific body that can particularly push forward with vaccine development. And this leads to discussions that take place in 1889, culminating in the idea of the British Institute of Preventative Medicine in 1891, that physically gets itself set up in Chelsea in 1893. It's quickly renamed the Jenner Institute of Preventative Medicine, and then because there's already a Jenner Institute elsewhere in the world, it then adopts the name of its founder, its president, and becomes the Lister Institute. And it's happily set up at Chelsea Bridge. And the mission statement, because even in those days, mission statements were the thing that defined what a company was there to do, for the Lister Institute, was to undertake fundamental scientific research into the causes, prevention and treatment of diseases in man and women and animals, to prepare and supply special protective and curative materials such as vaccines and antitoxins. And you can see on there like one of the first sort of proto-diphtheria antitoxins. But that's all well and good, but what they can achieve in Chelsea is somewhat limited, because a lot of the work that they're undertaking is developing anti-sera. And for anti-sera they needed animals, cows, horses, sheep and pigs. So they needed to find a farm. And after a search around, they settle on a place called Queensberry Lodge Farm, which is where we are today. And Queensberry Lodge Farm itself stands on very old ground, so it was the medieval ground of Aldenham Common. And we can trace back that there was a farm here to the 1830s, and the farmhouse, Queensberry Lodge, over that way, dates back to at least 1850. And at the time of Lister's acquisition, it was in the hands of the Ball family, and it was being used to train horses to pull the hackney carriages in London. So what are the taxis of today were horse-drawn, and the training of those horses began here. And the Lister Institute put a bid in for the farm, for the whole site, and it was accepted for the sum of £8,234, which doesn't sound a lot. And even today it isn't that much, because if you go to the Bank of England's inflation adjustment calculator, it was only the sum of today would be £816,100,000. And the biggest contribution to buy the site came from the Earl of Everley. And the Earl of Everley was better known as Edward Guinness, and he was the head of the Guinness family. And so a lot of the money that came into founding the site actually came from the brewing industry. So you could say that Guinness is good for you, and it's also good for the site. So in May 1902, we had the official opening of the Lister Institute at Elstree. And very quickly, the research started. So this is a photo that you may have seen around, and it's of a scientist called Charles Sheringham with a pony called Tom. And ponies like Tom were used for developing a diphtheria antitoxin. So diphtheria was a disease that was particularly prominent in the slum areas of Victorian and Edwardian London, and it's caused by a bacterium, a Corynebacterium, and it is possible to develop a anti-serum against it. So what they were doing was infecting the ponies with low doses of the Corynebacterium, letting the pony develop a degree of immunity, and then collecting the serum, the blood plasma from the ponies, and then separating out as best they could to get the antitoxins. So already there's a slight connection with the immunoglobulins of today, all slightly in a roundabout way. So the first person who was appointed in charge of the site was a Professor George Dean, and he was an Aberdeen University pathologist, and he was employed by Lister to look after the site. But he spent most of his time based in Chelsea, and there's some correspondence from him complaining that he had to come onto the site once or twice a week. So we're glad he did, because it gave us that establishment. But Dean was a man who sought connections with the local community. He built foundations with Aldenham School, and he also believed in the employees of the Lister Institute being relatively fit and healthy. So he encouraged lots of games and the playing of football at lunchtimes and after work. And there's an account of the staff at Elstree challenging the staff at Chelsea to a game of football. So it's one of the few times that you'll ever see Elstree beating Chelsea by 10-0. Then investment continued to trickle into the site, mostly in the form of new buildings. So across the course of the 1900s, there was investment of around £15,000, which is a more substantial sum, so that equates to about 1.5 million today. And this included a building called the Vole Vaccine Lab, where unsurprisingly voles were used, and this was for research into tuberculosis. And there was also a lab built called the Yersin Lab, and Yersin was the scientist who first identified the bacterium that causes plague, and we'll come back to plague in a few minutes. And then in 1914 the first cottages were built, so the first 4 of the Lister cottages date back to 1914. There was certain events that brought more work into the site, and one of them was the more unfortunate event of the First World War, where there was a big demand for particularly diphtheria and tetanus anti-sera. The site could continue because most of the staff working here were given protection from conscription because the work here was considered to be vital. And there was also another area of war-related research into gas gangrene that was taking place as well. Going back to plague, and this is again a really pivotal amount of work for the research. So around the late 1890s all the way through to the 1930s, there was a significant and very tragic series of plague outbreaks in India that affected around up to 1 million people. And because India was under British jurisdiction at the time, there was a lot of activity in trying to find out the causes and reasons for plague. At this time, it wasn't even established that there was the association between fleas and rats. So Sir Charles Martin, who was the overall head of the Lister Institute, went to India, did some research there, and then came back and said the role of the Lister Institute is pivotal in finding some cures for plague research. So he set up a special laboratory here, and then over in India people were paid what's equivalent to a very tiny sum, 1/16 of a rupee, to find dead rats that appear to be infected with plague, collect them up, package them up, and send them over to Elstree. And so Elstree was full of lots of plague infected rats at the time. There was an unfortunate incident that happened. So in order to advance the plague research, there was an eminent Australian plague specialist called Thomas Carlyle Parkinson, who took the boat from Australia over here to begin a lot of the plague research. Unfortunately, when he was working in the Yersin laboratory, he contracted pneumonic plague in 1909, and his digs were Queensberry Lodge, because Queensberry Lodge was converted into places for certain people to stay, and he went back that evening into Queensberry Lodge, and then unfortunately he died in the lodge, which may or may not explain the strange ghost-like sensations that some people have experienced. And his body is buried in Aldenham Churchyard. So there is a unkempt kind of grave. It takes a while to find it, but the gravestone is still there about 2 miles away in Aldenham Churchyard. Okay, so some other things that were happening on the site. So there was a very eminent scientist, Dame Harriet Chick, and she advanced protein denaturation. She was also the founder of the Nutrition Society, and she also created one of the first laws for disinfectants. And she worked here all the way up until the late 1950s, but then continued to come in up until the age of 100. Another important researcher was Muriel Robinson, and she did studies into African sleeping sickness, and a lot of her work was actually very important against this parasitic disease that was rife and still is around today in parts of sub-Saharan Africa. And for a lot of her research, she was infecting goldfish and leeches. And for that, she needed a reasonably large body of water. So she would pop over to Aldenham Reservoir to do certain things, but she was also using the pond in Queensberry Lodge for that purpose. So if you ever do get tempted to go paddling, just watch out if there's any mutant leeches still left in there. The second person in charge of the site was Alfred Theodore McConkie. McConkie today is best known for a microbiological culture medium that he invented called McConkie agar, which is used for screening for fecal microorganisms, particularly E. coli. And he invented his agar because, it may seem strange now, but at that time, some of the water utility providers were releasing sewage into waterways, and they needed to do something about that. But we've moved on beyond that. But McConkie was also a hard disciplinarian. He was very, very different from his predecessor. He was known as the dictator, and he banned all of the lunchtime sporting activities because they were getting in the way of work. So there were other important things that were taking place on the site as well. So there was further expansion of the work into tetanus. There was research going on into polio. There was research going on into scarlet fever. There was some important work that was done, and again, some of these things now seem obvious today, but rickets was another common condition. So Harriet Chick did a lot of work on improving the nutritional quality of cow's milk, particularly of maximising vitamin D. So she did a number of experiments with the amount of light that cows are exposed to and altering their feed in order to help the population at large. There was research done into the pathogenicity of E. coli, and there was also the founding of the National Collection of Type Cultures, which exists today as part of Public Health England, and it's the UK's main repository of microorganisms. And the money that came in that keeps the site going is largely, again, still drawn from the Guinness family, but also from Rockefeller himself, and then later the Rockefeller Foundation in New York. Now, smallpox is what the Lister Institute is perhaps, or should be best known for. So smallpox was a disease that humanity had to contend with for thousands of years. You can go back to Egyptian mummies and find scars of smallpox infections. And smallpox was a horrible disease. It's something that began with a severe headache, backache followed by fever, then a rash, then spots, then watery blisters. And then if you survived, you would have scars. You might be lucky and survive with just the scars. You might survive and be blinded, or in around sort of 40% of cases, it was fatal. And smallpox was rife around the world. So there were a number of efforts that were put in to develop vaccines against smallpox, and a lot of these early vaccines were what known as lymph vaccines. So they were developed in calves and sheep. Then sort of more purified vaccines were developed, but a lot of these were in liquid form. So what was happening in the course of the sort of 1940s to the 1960s was that liquid vaccines were used to eliminate smallpox in the world's sort of richer countries. In the UK, it was around 1960 that smallpox was finally eliminated. There's an interesting newspaper cutting from 1958 when the Lister Institute at Elstree delivered an emergency supply of vaccines to the England football team because they were due to play Scotland in Glasgow, and there was a sudden outbreak of smallpox in Glasgow, and they wanted to protect themselves from anything they might contract in Scotland. So apologies to anyone who's Scottish. What the main contribution of the site was, it was developing a smallpox vaccine. And the smallpox vaccine that was developed by the site was the world's first freeze-dried vaccine. And the person who pioneered freeze drying at Elstree was Leslie Collier. And he was a virologist and a bacteriologist. And he joined this site in 1948 at the age of 27. And he was here all the way until the Lister Institute closed down. And his freeze-dried vaccine, the Lister strain, was adopted by the World Health Organization, and it was the primary vaccine that led to the eradication of smallpox from the planet. So this site was absolutely critical in ridding the world of its first major disease. The other thing about Collier's work is that the freeze drying that he developed became the basis of the freeze drying that was then used for the plasma products. But let's move over to plasma products, because there's now certain things happening in parallel. So at Elstree, there were two people who were really important for those early plasma product researchers. So there was a man called Arthur Macfarlane, and there was a man called Ralph Keckwick. And Macfarlane had recently been to Sweden to work with a man called Swedberg, who had developed the world's first velocity ultracentrifuge. And it was this centrifuge that allowed for the first time the realization and separation of proteins from plasma. And the Lister Institute then purchased the only the second of these ultracentrifuges in the world in 1937. And this centrifuge was an oil turbine powered one. It was purchased purely from a grant from the Rockefeller Foundation for £3,400. And it was used at this site from 1937 until about 1969. And it was used for plasma protein work, but it was also used by other scientists. So there was a lot of work done into the tobacco mosaic virus as well. And the centrifuge, as you can see from the screen, was donated to the Science Museum in London. And it's still there to this day in the sort of main foyer, and there's a small plaque there saying donated by the Lister Institute. So the ultracentrifuge was used. There was also then advances taking place in electrophoresis, for which Keckwick was an early pioneer, and there was a lot of use of photographic plates to look for sedimentation of proteins and so on. There was also important work taking place in the US, and this was undertaken by Edwin Cohn. And in 1941, Cohn began to develop ethanol fractionation. And with his ethanol fractionation process, he was able to separate out 1 to 5 fractions. And he was particularly interested in the 5th fraction because he could develop a stable plasma protein solution that could be used for the early treatment of shock. And Cohn had on his wall, his motto was blood is a very special juice. Another important pioneer in plasma products was a man called Charles Richard Drew. And what he was pushing forward was the collection of plasma from the US in this kind of crude albumin, this plasma protein fraction. And he was subjecting it to freeze drying and then shipping it to the UK in what was called the Plasma for Britain or the Blood for Britain campaign. And this crude freeze-dried albumin equivalent was then being used in the battlefields and in bomb sites to find people who were injured and to give them a chance of success. And the success around this led the UK government to push for something similar. So the Medical Research Council and the Lister Institute at Elstree, this sort of early exploration work, came together to begin the path towards UK plasma products. So the UK began a similar process, and the pioneer behind that was Ralph Keckwick, but he wasn't able to use ethanol. So he read all about Cohn's research. He began to play around with things, but ethanol was incredibly hard to come by, and that's because all the ethanol supplies were controlled by the British Army, because ethanol was required to make TNT. So he couldn't get hold of ethanol. Instead, he used ether. And ether, Keckwick, all the way through to the end of his life, felt was superior to ethanol. It just had the slight downside of being very, very volatile. So volatile that a special health and safety proviso was put in the proto-fractionation area, because they were very, very concerned. So they fitted a small rack outside so that the people going in had somewhere to leave their pipes, just in case there was anything to go wrong. The reason there's a picture of a bottle of Johnny Walker on the slide there as well is because for the British plasma, to make the first freeze-dried plasmas, they didn't have enough glass bottles. So they found the Johnny Walker bottle and the Gordon's gin bottle particularly suitable for putting plasma into. I'm not quite sure who had to drink the contents in order to get the bottles. Okay, so here we have Ralph Keckwick. So he is, in my opinion, the father of the plasma production at Elstree. He was the inventor, as said, of the diethyl ether fractionation process, which today is used in diesel engines. But anyway, he was also the first person to create what would be considered factor 8 from the purification of cryoprecipitate. He did this in 1957, but it really took until the early 1970s to create a stable and reproducible process. So another milestone was that in 1943, Elstree came under the jurisdiction of a man called Sir Alan Dury, and he became the Institute's director. And he asked for a separate department to be set up called the Blood Filtration Unit, and it was set up with Keckwick in charge, and he was assisted by another scientist called Margaret Mackay. And by 1948, this had become the Blood Products Research Unit, and then in 1954, the Lister Institute, together with the Medical Research Council, decided to set up a full-blown department, and an autonomous division within the site. So you had people who were employed by Lister, administered by the MRC, funded by the government, but it was essentially a separate company. And that's the company that many of us were employed by, leading through to the merger with Kedrion, and that was BPL. And the main building at BPL, the main factory, was also constructed the same year. And where we are now is actually where the factory was. It was called Building 25, and it was built in 1954 for £175,000. The first person in charge of BPL was Sir William Maycock, and he was given the title as the director, And he actually plays a really important role not only in British plasma products, he was also one of the founders of the blood transfusion service. So in World War II, he was running effectively what became the National Blood Transfusion Service straight after World War II. And he had a very, very long time in charge of the site from 1954 through to 1978. Some other developments. So not only was the site working on the purification process of albumin and developing its work with cryoprecipitate. In 1947, it was identified that the gamma globulin fraction had sufficient natural antibodies to help to fight disease. So BPL began to roll out its first IgG around that time in fairly low quantities, and it was used primarily as a way to help combat people who had measles infections. And at that time, all of the IgG, all of the what became the normal immunoglobulin, was all administered through the muscles in small quantities. Over in Oxford, Rosemary Biggs and Gwyn McFarlane were not only exploring the properties of cryoprecipitate further as a way of factor VIII replacement, they also pinpointed a way of creating and purifying factor VIII, and they also were the first to put forward the first factor IX. And this research at Oxford suggested to Lister and to BPL that they needed a research and development department. Also taking place over in the US was the development of the first factor VIII assay, and this was pioneered by a woman called Judith Paul, and her work led to the means to produce available factor VIII by up to 20%. And this factor VIII, the first factor VIII to be developed, was about 97% clottable. So this concept of blood products and the potential for the proteins to offer more, and this concept of research and development led to an extension of BPL opening in Oxford called PFL, which was the Plasma Fractionation Laboratory, and this was based at Churchill Hospital in Oxford, and it was run by a scientist called Edith Bidwell for most of its duration, and then it was run by a man called Jim Smith. And this facility remained open until 1992. There was a small R&D function that was formed in BPL in the early 80s with a guy called Mike Harvey in charge, but really it took the closure of PFL and the transfer of the staff and the assets to the site for R&D to be established, and the R&D building that we know today was then opened. But the primary success of PFL was with purifying factor VIII and in developing factor IX. There's other things that are taking place then as we move into the 1970s. So BPL continued its research into IgG. There was actually one for a little while produced that would help against people who suffered severe reactions to bee stings, but that was never continued, but apparently it did work. The first anti-rabies immunoglobulin was made in 1977. Chromatography was introduced in 1979, which improved the purification of products immensely. There was also a radioimmunoassay developed in 1975 that was so successful it was adopted by the British, European and then the United States pharmacopoeia. By 1978, the site was processing 1,200 litres of plasma, and it had its first MHRA inspection in 1979. Apparently it wasn't particularly great. Mostly the state of the buildings needed a bit of work. So just looping back to the Lister Institute. So the Lister Institute at Chelsea closed in 1975. It continued to keep the site ticking over until 1978. The problem was that the smallpox vaccine was so successful and there was so much energy put into it that as soon as smallpox was eradicated, Lister didn't really have anything else in its pocket. And the donations began to dry up. The government was approached, but they weren't willing to invest. So Lister closed down all of its manufacturing operations, and it exists today as a charitable trust. But fortunately for the future and success of BPL, the government stepped in and it purchased the entire site, and BPL became the sole occupant of the site. And Maycock retired, and a man called Richard Lane took over the site, and he was in charge from 1978 to 1990. There was also a special health authority that was formed to look after not only BPL but also the PFL in Oxford, but there were two other parts of the blood products dimension. One was the International Blood Group Reference Laboratory, which again still exists today as part of the National Blood Service, and also there was a Blood Products Diagnostics Division that operated on the site until 1996. Other milestones, so the introduction of heat treatment of albumin began in 1980, and that obviously had a great success in advancing patient safety. And then the world's first heat-treated factor VIII came along in 1985, and again that process for the safety of patients was immeasurable. By 1982, the British government decides that the UK should be self-sufficient in blood products. At that time there was a mix of products made in the UK and some imported from abroad. So plans were drawn up for what is the Building 27 of today. So Building 27 started, there's an artist's impression on the slide. With then dropping down, we've got the laying of the foundation stone with Norman Fowler. Then jumping above, we have the Duchess of Gloucester doing the official opening. And then to the side is Kenneth Clark and Richard Lane in probably heat treatment. And then we have sterile ops loading a freeze dryer without any grade A protection at all. So the factory was built at a cost of 60 million, which at today's prices would be 175 million. It opened in 1987, but it wasn't really up and running producing commercial batches until 1989. Some other important things that happened was that in 1989, Crown immunity was voluntarily surrendered. So that meant anything up to that point, if anything bad happened, then BPL was under full legal protection of the monarch. So you couldn't theoretically sue anything under Crown immunity because you can't actually sue the monarch. But that was surrendered, and that was the path towards becoming a grown-up pharmaceutical company. In 1990, the name changed from blood products to bioproducts, and a lot of that was to kind of fit in with the internal market within the NHS. Because from that point, clinicians in the NHS no longer had to take a BPL product without any alternative. They could also then go and purchase from other companies if they wished to. We also saw the first marketing department. So you can see how things have changed from today, but that was a man called Norman Pettit, who was the first marketing manager at BPL. And we also had in 1990 the first person in charge of BPL, so Richard Lane retires, and the new person in charge is now given the title CEO rather than director, and he comes from ICI. So they bring in somebody in with some commercial acumen, and that was a man called Richard Walker. Some other things that take place, so the CBLA is abolished in 1993, and BPL merges with the National Blood Service, so you bring in red cells and plasma together. There was, as is perhaps well documented, in 1998 there was the advent of a new variant CJD and the potential for people, if they'd eaten certain beef products, to have a prion that could potentially be transmitted through the remaining white blood cells in plasma. It was all highly theoretical, but the risk was such that there was a ban placed on UK plasma, and because of the huge importance of the site, you know, it was the national fractionator, the British government went out and purchased 24 US plasma centres that were run by an American company called DCI. Initially, these plasma centres were not part of BPL, they were kind of run separately, but they provided a vital pipeline of plasma to the site. Other important milestones was the first large volume immunoglobulin. Initially it was freeze-dried and it was called Vigam, and then it became a liquid variant of Vigam, and then to the Gammaplex that we know today. There was also the development of the first high purity factor 8, which again made the lives of patients so much easier, and this was Optivate. Oddly, it was under the name of Project X, which wasn't a reference to later Factor 10, but was the name that the scientists wanted to give it at the time. And there was also another key thing, so something I haven't mentioned, is that there was a Scottish equivalent of BPL. It suffered with a lot lower investment. So BPL's remit was England, Wales and Northern Ireland. PFC looked after Scotland. And in 2004 it was decided to close PFC down, and BPL then became responsible for all of the UK. Some other things then, just to bring us up to date and to bring this talk close to an end, was that in 2011 BPL was moved from the NHS and placed under a company that was wholly owned by the Department of Health, and that was called Plasma Resources UK, or PR UK. Then in 2013 Bain Capital purchased about 80% of BPL, with 20% held by the Department of Health, and that led to a huge amount of investment coming into the site, and it allowed the purchase and installation of line 3. So that's really pushing the site into new directions. Then in 2014, there was we mentioned at the all hands meeting the importance of Coagidex, and Coagidex was launched in 2014, and that became another pivotal product to BPL's portfolio. Then in 2016, there's the sale to Creat, and that's 100% sale, and that allows greater investment and stabilisation. And then we have the merger in 2022 with Kedrion, and further development, investment, and the ability to grow and be supported for what is now going to be a really exciting future. So that brings the talk to an end. What I've attempted to do is just to give a very potted history. There is obviously a lot more detail, but hopefully it gives you a flavour. And I think that the key thing is just the sheer importance of the site, the wondrous scientific inventions, everything from improving nutrition to addressing diphtheria, eradicating smallpox, but also the pioneering legacy of plasma products. The first step forward in factor VIII, the first immunoglobulins, and so on. And so successful was BPL at the time that Australia was struggling to get its plasma protein up and running. So BPL went down, some people went down there, and they handed over all of the technology to the state-owned facility in Australia that was called CSL. So CSL today had got a very kind of big lift up from us. So anyway, that's enough of me rambling. I'd like to especially thank Suzanne and Kate for helping to put this together. That's been fantastic, and thank you to Richard for allowing me the opportunity. And thank you, and happy to answer any questions. So would anyone like to ask anything?
So you talked about how we got more investment by the fact that we were bought by a company and another and so on. Would there be any real benefits of us having continued to be part of the NHS? So which are the benefits of being part of the public health system versus being a private company, in addition to just having a lot of more money to invest?
I think we probably, this is again all my personal opinion. I'm not sure we would have necessarily survived. Across the desk of lots of ministers over the years were whether to keep the site running or not, simply because of the sheer amount of money that was required. So I don't think we certainly wouldn't have been anything like we are today without the private sector money. We just couldn't have competed, so we would have been a very small scale UK provider, but then it would have been cheaper probably for clinicians to have purchased medicines from other companies because our costs would have been so high. That's my opinion. I don't think we could have kept going.
Thanks. Tim, who was your favourite character in all the scientists and people that you researched?
That's very tricky one. I think for plasma products, then I think Ralph Keckwick it should be really seen as a hero for the site. I mean, we really probably should have a blue plaque up somewhere for him, because he was the person who did all the initial research into protein science. He there's early papers by him describing. He was the first person to apply electrophoresis. He had to step in and come up with a fractionation process that wasn't based on ethanol because he simply couldn't get hold of it. And he was the first person to produce like a purified factor 8. So I think he really needs to stand up very, very high in the pantheon of people. I do have a lot of sympathies for Thomas Parkinson, who contracted plague. That was really unfortunate, because the thing is, when you look back, he was hugely celebrated in scientific circles in Australia, and it was very much, please come over, we'll increase your salary, we really need you here to help with the plague epidemic. He's here for a few weeks, and that's the end of him. I think between those two, I'd go with him. Okay, any other questions?
Do you think we'll ever be able to use British blood rather than American?
That's in theory, but it's something I'm not overly knowledgeable of. I'll let Richard answer at the next town hall. Okay, anything else? Okay, well, thank you very much, and hopefully there were some interesting things that you learnt for that. Thank you.